we are starting chapter 3 now. And so in chapter 2, you started learning a whole bunch of derivative rules. You know, you got power rule, you've got rules for what's the derivative of sine and e to the x and b to the x and all of these things. So when we start chapter 3 here, what we do is we look at what happens and how do I do derivatives if I'm combining them in more ways than adding and subtracting, because that's all we did in chapter 2. You'd have, you know, x squared plus sine of x, and you take a derivative. Now, what we would look at this now, what happens if we are multiplying those? What if we're dividing those? And then later in chapter 3, we'll look at some more ways to compose functions and then take derivatives of those. Okay, so this chapter we are going to learn something called the product rule, and the quotient rule. So by product means we're multiplying things, and then quotient we're going to be dividing some things. Okay, so here is going to be your product rule. Now I'd like to point out that these are function notation, so this is not times x, this is p of x is equal to u times v, and then those are the of x, not times x. So here the product shows up with that it's u times v. So another way to write this is p equals u times v. So if those x's confuse you, you can write it like this. Okay, and so here we kind of break it down. The way that it's going to go is it's the derivative of the first times the second. So it's the derivative of the first times the second term, and then plus the first times the derivative of, I'm going to write second instead of this. Whoopsie, sorry. Let's try that again. There we go. Struggle. Times, okay, let's, times the second. I can't put it, all right, let's try that again. All right, so it's the derivative of the first times the second plus the first times the derivative of the second. And so by first, I mean this u, and by second, I mean this v. And so here's that notation. It's going to be u prime times v plus u times v prime. And so there's the function notation version. Here is the version without those x's that might be a little more clear for you, just in case. And so, and even instead of p, I put u times v because that's what you're doing. Okay, so once you have that written, we'll do these two examples here. So the first one, I have y equals x squared times e to the x. And so this is where your product has to come into play because you do not have adding or subtracting here like you did before. So we're going to have y prime. So what comes first is the derivative of the first. So that would be 2x. And then times the second as is. So e to the x. And then plus the first as is times the derivative of the second. Well, the derivative of the x is just e to the x. So that would be your derivative. Okay, let's try one that's got a little more to it. Go down. Here we go. All right, so let's do 8 tangent of x times 2 to the x. So we're going to throw in some of these other derivative rules that you had that we've just started practicing a little bit, and we'll practice them a lot more going forward in chapter 3 here. So I'm going to denote this as f prime. Now in this case, my first is this 8 tangent of x. So we just attach the 8. It works just like a constant that you had back in chapter 2, that it's just going to stay 8 times. But then we'll work with the derivative of this. But I don't distribute anything because these are all just multiplying. So there's no adding, so you don't have to distribute anything. So the derivative of tangent is that secant squared. So the derivative of the first times the second, so times 2 to the x, plus the first as is times the derivative of the second. And I'm going to put this in parentheses because 2 to the x power ln of 2, these are all being multiplied. You wouldn't necessarily, this is the times symbol there, that you are timesing those. Now this answer, you can leave it like this. Like that is perfectly right. When you look in the back of the book, they will kind of reorder a little bit just to kind of clear things up. One thing that I do want to talk about in terms of simplifying that is wrong, and one of the reasons we don't want you to do it, is I will often get students tell me that is 16 to the x power. But remember, this power, this exponent is done first, and so you cannot combine with that 8. That has to stay there. So this one, they might reorder as this, just because they like to kind of have all things ordered, and then sometimes it appears something could be inside secant if it shows up after. So they like to put the 2 to the x power there. This one, they like constants first. So technically, natural log of 2 is a constant, and then it'd be times 2 to the x tangent of x. Now, this is one way to order your simplifying, but you don't have to do that on any homework assignments, on your AP test. The only way you'd maybe have to do this is if it was a multiple choice, and then you had to go find what answer this was the same as. So then you might need to do some reordering, but otherwise, if it is not multiple choice, be done here. No matter how crazy looking it is, be done. All right, so that is your product rule. And again, derivative of the first times the second plus the first times the derivative of the second going there. So now let's look at quotient rule. So quotient rule, we're going to be dividing. We can't divide by 0, so that just kind of is part of your definition. So we just kind of, again, this is function notation, but it's u over v. So I'm going to, I don't love the horizontal, so let's just make it this instead. U over v prime. So how your quotient rule works, the top is the same as the product rule, except we're going to subtract. So it's the derivative of the first times the second minus the first times the derivative of the second. And I know in the product rule, you technically could do these in either order because you're adding, and adding is commutative. But when you're subtracting, that is not the case. So if you stick with that derivative of the first times the second, you just switch to a minus in this one, and then the first times the derivative of the second, or the bottom in this case. So in this case, I'm saying my first is the top, my second is the bottom. Then you're consistent between both the product and the quotient rule for that. The quotient rule then does add divide by the bottom squared, or v squared, or the second. So you can call this top and bottom if that's easier. You know, either, however, whatever you need to do to remember this. So let's try one. So we have 3x plus 1 over sine of x. And so, you know, yes, there's some adding and subtracting up here, but your overall format is a division, a quotient. And so that's how you know you're going to need your quotient rule. Okay. So it starts off the derivative of the top, or the first. So my derivative of 3x is 3. My derivative of 1 is 0. So I can just put 3. And then times the bottom minus the top as is. Since there is addition, it does have to be in parentheses, and then your derivative of sine is cosine. Okay, and then it's over the bottom squared. Just be careful, if you remember back to pre-calc C, if you have sine squared, you put the squared between the n and the x, because if you write this, it appears you are squaring the x, not the sine. This would be okay, but this is going to be what the notation you see going forward as well. And so start getting used to that if you didn't get used to it in pre-calc C. But at the minimum, do this. Just make sure there has to be parentheses there if you're going to write it like that. All right, let's work with these a little bit and make sure we are good. So let's find p prime and q prime. So here's p, x squared times sine of x. So p prime, derivative of the first times the second plus the first times the derivative of the second. And this section in this chapter in general is going to help you really get used to these rules of what is the derivative of what and antiderivative, because you're going to be doing a lot of them. Okay, so pause the video here, try q prime, and when you think you have it, hit play and see if you're right. So q prime would be the derivative of the top, which is going to be that 3x squared times the bottom minus the top times the derivative of the bottom. And so your derivative of the bottom in this case would be negative sine of x, and then over the bottom squared, so cosine squared of x. This is totally fine. You know, some people, if you notice you're getting a negative in there and you change that to a plus instead, that's fine. Oh, there you go, cosine squared. So if you want to move that negative so that those two negatives will make a positive, that's fine. These are multiplying, so there's no distributing, there's no making anything negative out here. This is just a negative x cubed times a negative sign, which makes it a positive on there. But again, you can leave it like this. You do not have to simplify. All right, let's work on finding the derivative of tangent. One thing, kind of a throwback from pre-calc as well, you might be thinking, well, tangent, that's not a product, that's not a quotient, why am I doing that in here? Well, one little fact from your trig days is that tangent of x is actually equal to sine over cosine. And your reason is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. Instead of dividing by a fraction, I can change to multiplying by the reciprocal. H's cancel, and so you get opposite over adjacent, which is what tangents is. So I can make this into a fraction. It is sine of x over cosine of x. Now you might have memorized what the derivative of tangent is, but if they want, you know, we're going to prove it basically that it is secant squared on here. Okay? So when I go to my quotient rule now, y prime, it's the derivative of the top. Derivative of the top is cosine times the bottom, which also happens to be cosine, minus the derivative, or the top as is, excuse me, times the derivative of the bottom, which is negative sine. So just like up there, I'm going to simplify there, and then all over your bottom squared. Okay, so just doing some simplifying since I'm proving to you that it is secant squared. Cosine times cosine is cosine squared. Sine squared over cosine squared. You cannot cancel those because you have to first add these two together. And at the very end of your trig day 2, we talked about how there's some trig identities. There's one that can show up on your AP test, and it's this one. And then it's cosine squared plus sine squared equals 1. So this is 1 over cosine squared. And then if you remember your reciprocal functions, 1 over cosine is the same as secant, and then it's just squared because of that. Okay, and so, sorry about that, this is jumping, there we go. There. So the derivative of tangent is secant squared, which was one of your rules, and you've already been told that, but just to prove it to you. All right, so just some other things that you can add to, you know, if you made a note card, if you have a running page of here's all my derivative rules. Here's a few more. I would say the one that shows up the most is the derivative of secant, just because you'd have something like take the derivative of tangent and then take the second derivative, and your second derivative would have a secant in it then. So it becomes secant tangent is its derivative. So this one is crossed off because it should already be on your list. These three are not. So go ahead and add those on there. You can pause the video if I go too fast here. And then here's one more. We did not have the antiderivative of natural log yet. So the antiderivative of natural log is this x natural log of x minus x plus c. So if you need time to write those, go ahead and pause the video. Otherwise, we will keep going. All right, we're going to bring back some different exponent rules and then combine them with product and quotient. So we want to use product and quotient to differentiate these two items. So the first one, I'm just going to call this, we'll say m. M equals e to the 2x. And so right now, it's kind of, this isn't product or quotient right now. This is like a 2x plugged into an e to the x. So we somehow need to simplify it so that I have two things, either multiplying or dividing. In my case, it's going to be multiplying. Because when I get that 2x, I can change it as e to the x times e to the x. So same way, in your homework, you had this show up. I think it was, I can't remember the base number, but I do think it was 3. And so you had to reduce it first to 3 to the x over 3 because you've got really like a power of 1, and then you'd be subtracting. That's going to come into play with this one. So this, I had the same idea that I had to break up my exponent. And in this case, I wanted to break up a 2x as x plus x. Okay, so now m prime, derivative of e to the x is e to the x times the second, which is e to the x, plus the first as is, times the derivative of the second. And then that's it for your product rule. Now, if you notice, you have 2e to the 2x's. So the derivative of e to the 2x is 2e to the 2x. Okay, we'll call the next one n. I don't know, e to the negative x here. All right, so this one I need to write as some kind of power, something with e to some regular power. And so I can do that by reciprocating it. Now, kind of weird, but when I go to do my quotient rule, and you do the derivative of the first or the top, the derivative of 1 is 0. And so you will have a times 0 there. And then the derivative, or the top as is, times the derivative of the bottom over the bottom squared. I'm going to write it like this for a second here. So I'm going to simplify. 0 times is gone, so I'd have negative e to the x over power to a power we multiply, so e to the x squared, or 2x, excuse me, 2x. And then if I subtract my powers, I would get negative e to the negative x. So there's a little bit of a pattern there. You might be able to see that, but that will be coming up actually in 3.2. We'll talk about why that is and what happened. Now the last example we have, we're going to go over, sometimes you can get more complicated. That it's not just 2 things multiplying, maybe it's 3. Or maybe there's things multiplying and things dividing, and we'll increase the combinations of these as we work forward. So we're going to start that process by doing this u, v, w derivative. So I have 3 things multiplying this time. Now you don't have a product rule for 3 items, but what you can do is group some things together. So I'm going to group u and v together. So now this is my first and this is my second. Okay, so when I write out my derivative, I'm going to do it kind of notationally, and then we'll expand from there. So my derivative of the first notationally is uv prime, and then times the second, which is w, plus the first, which is uv, times the derivative of the second, which would be w prime. Now when I look at this, like w prime is fine, this is fine. This is another product rule, because I have 2 things multiplying that I'm then taking the derivative of. So that thing is going to expand into its own product rule with w prime, with that stuff after it. So my product rule for this product would be u prime v plus uv prime. Okay. And that answer is fine. You've got it listed in terms of originals and derivatives. When you're getting these things, kind of the recommendation, and Ms. Marshall and I will talk through them as you have us in class, like in 3.2 and in later sections, but you really need to write down your steps. Don't try to do too much into one at one time, and you get kind of confused of where everything is. You know, use this notation of prime and derivative so that you can, like I said, do this in pieces like I just did, and then you take other pieces and kind of expand those as you go. So the more you can jot down and write and put your thoughts on paper, the more successful you are going to be. All right, so you can look on Canvas. The homework assignment is on there. I believe it's page 166, but the numbers will all be listed right on Canvas there. So good luck.